All right, welcome to week 11 practice problems. Then the first problem that says in the figure below, line AD is parallel to EH and BF is parallel to CG. What is the measure of angle FGC? Okay. So the first thing I would do is I would maybe mark that these are parallel and that these are parallel, just so that I can kind of see that. But what this means is I've got parallel lines with transversals. So since all the lines are kind of parallel to each other here, these two sets, that means that basically every obtuse angle is equal to every other obtuse. So basically everything that I color in black here is going to be equal to whatever else is in black. So these 8 angles are the same. Now you notice one of them is 2x plus 19, but none of the other ones that they give us are equal to 2x or are obtuse angles. The other ones are the acute angles. So I can kind of see that these are the acute ones, the green ones, and that means that the other one, this 3x plus 14, is going to be my other angle. So basically what I know is that since all the lines are parallel, these two should add up to be 180, okay? So that's all we got to do is solve this equation. So I combine my like terms, 2x and 3x make 5x. 19 minus 14 is a plus 5. That equals 180 degrees. So take away 5 from both sides, it gives you 175 is equal to 5x. Of course, the last step is to divide out the 5, and I get that x is 175 divided by 5, which is 35. Now remember, from the very beginning, if you had trouble with this, you could have graphed left and right sides and found the intersection, and you would have then found 35. But this one's pretty straightforward. The answer choice B, 35, is the correct answer. All right, number 2 says if line A is parallel to line B, then what is the value of B? Okay, so what they're saying is that these lines here are parallel to each other. It's kind of bad that they use the A and the B as lines and as variables. You won't usually see that, but we'll go ahead and try to make sense of what's happening here. So basically what that means is that I'm looking for this angle right here. Now, since these lines are parallel, I know that this angle would be the same as B, okay? So the question is, can I figure out this angle right here, okay? That's my question. So what we're gonna do is try to figure that out. Well, first off, I see a bunch of stuff right here in this circle. I think what I could do is I could realize that if this is 20 right here, then this has to be 20 because it's a vertical angle. If this is 4A here, then that means across the way should be 4A, and that if this is 3.5A plus 10 because of that vertical angle. All those angles across the way from another set of lines like that are going to be equal to each other. Those are vertical angles, okay? So now that I know that, I think what I can do then is I can say, well, there's 360 degrees in this circle. So that means that 3.5A plus 10 plus 3.5A plus 10 plus 20 plus 20 plus 4A plus 4A has to equal 360, okay? And basically I'm solving that equation. So I've got all sorts of A's here. I've got 3.5 and 3.5 and 4 and 4. If I add those all together, I'm gonna get 15A. I've got numbers here, 10 and 10 and 20 and 20. That makes 60 total. So that's gonna equal 360. Okay, so I just solved this equation. Take away 60 from both sides. I get that 15A is 300. Of course, if I divide out the 15, I'm going to see that A is equal to 20. Okay, so going back to this problem, really what I'm trying to do is figure out this measure of this angle right here. All right, now it's comprised of 2 different things that I know. I know this part is 20, and I know that this angle here is 3.5A plus 10. So together, what do they make? Well, just add them up, right? 20 plus 3.5A plus 10. Well, we know that A is 20, right? That was why we solved for A. We had to know what A was. So 3.5 times 20 is going to be 70. So really, 20 plus 70 plus 10 is going to be my answer. That's 100 degrees. So that tells me this angle right here is 100, but because these lines are parallel, that means this and this should be the same. So that means B should also be 100. Okay, now from the very beginning, right, I chose to add up all 6 of these angles and equal them to 360. Okay, I could have just taken half of it. I could have just taken these 3 pieces here, which, if you could see by my picture, was 3.5a plus 10, and there was a 20 and a 4a. I could have added those and gotten 180 because they make a straight line. They're a linear pair, or a linear group, I guess. That would have been just as easy. It would have given me the same answer for A, and then I could have reasoned it the same way. But either way, that's kind of the basic idea here. All right, in the circle below, a chord measuring 20 inches is bisected by a segment that goes through the center of the circle. If the segment measures 12 inches, then what is the radius of the circle? Okay, so this problem, you got to know the radius of the circle. Well, how is the radius connected to anything that's going on in this picture? Well, that's the radius, right? Now, what you got to know is that this line segment that connects the chord is perpendicular, okay? That means we have a right triangle, okay? Now, if we have a right triangle, since this entire length is 20, that means half of the length is 10, right? We're just talking about this side of this triangle. So that side is 10, we've got a right angle. We know that this line segment was 12. The question is, what is the radius of the circle? So this is Pythagorean theorem all over the place. We know 2 sides. We want to find a 3rd side. We're going to use Pythagorean theorem. Okay, so A and B are 12 and 10, and C is going to be our R. So that means 12 squared plus 10 squared equals the radius squared. And we just solve for R. So 12 squared is 144. 10 squared is 100. That's equal to the radius squared. I get 244 is equal to the radius squared. That doesn't tell me the radius, it tells me what the radius squared is. So I square root both sides, that kills off the square. It leaves me with the radius is the square root of 244, and we're done. Now I look at my answer choices, I don't see anything like that, okay? So first thing you can do is you could use your calculator, right? Square root of 244, what is that? Well, the square root of 244, this is gonna give me a decimal, it's 15.62, okay? So it can't be A, that's not 15.62. B, I don't know, maybe. C, I don't know, maybe. It can't be D because it's not 16.2. And if I think about it, the square root of 16 is, excuse me, the third choice is 16 times the square root of 2. Well, the square root of 2 is 1 point something. So would it be possible for our answer of 15.6 to be correct? No, 16 times something bigger than 1 will be bigger than 1. So I could actually choose E as not being the choice. So really, I narrowed it down to 2. That's pretty good. I can just guess and check with these. So I'm going to guess it's B, or I'll guess it's C. I don't know. So what I'm going to do is I'm going to plug it in here. 3 square roots of 29. So 3 times the square root 29. 3 square roots of 29 is equal to 16.15. So it's not that answer choice. That means it's got to be B. 6 times the square root of 21. So 2 square roots of 21. 2 square roots, that's not at all what it says, sorry. 2 square roots of 61. There we go. 2 square roots of 61. Sorry, I'm having trouble there. 2 square roots of 61 gives me 15.62. Exactly what I had up here, so that means it has to be my answer choice, B. Now, if you didn't want to go through all that trouble, you could just reduce the 244. You break it down. The square root of 244 is really the square root of 2 times the square root of 122, right? I just factored that into 2 numbers that multiply to be 244. I realize that square root of 2 is a prime number, so I leave it. This is going to be the square root of 2 times the square root of 61. Basically, 2 times 61 is 122. 2 is prime. 61 is actually prime as well. It doesn't break down any further. So I combine my two 2's, square root of 2 times square root of 2 times square root of 61. These 2 make 2, and then I have the square root of 61. So that's really the better way to do it. It's pretty fast. You don't want to just guess and check on a bunch of things, but if you had to, you could. Okay. All right, triangle ABC is isosceles. What is the measure of angle ACD? All right, so we have an isosceles triangle, and we're looking for the measure of this angle right here. That is what we're looking for. Well, I can tell if I could find this angle here, right, then I just do 180 minus that, and it's going to be my answer. So all I got to do is find really the base angle here. So remember, if these two are equal, it means these two angles are equal as well. Those opposite angles are defined by those lengths of those opposite sides. So if the opposite side lengths are equal, it means those opposite angles are equal, okay? Now we know we've already used up 50 out of our possible 180. So if I take away 50, I get 130. Well, these two angles should add to 130 then. But since they're the same, it means we have to divide that by 2. We get 65 for each one, okay? So that means this angle here is 65 degrees. So if this is 65, what number would have to be here? Well, it's 180 minus 65, which is 115. So answer choice A is correct. All right, next question. The two legs of a right triangle are 5 and 12. What is the length of the hypotenuse? All right, so first off, it says we got a right triangle. The legs, remember the legs are these bases here, 5 and 12, and we want to know what the length of the hypotenuse is, right? We should know this answer immediately right now. If you remember your special Pythagorean triples, the answer is given to you. Well, let's pretend we don't. We would use Pythagorean theorem where a squared plus b squared equals c squared. 5 squared is 25. 144 is what 12 squared is. That gives us x squared. 169 is x squared. We square root both sides. If I get my calculator out, I realize that the square root of 169 is 13. So this side has to be 13. Answer choice D. But really, the point is that you should be able to remember 5, 12, 13. Okay, any multiple of 5, 12, 13 is a right triangle. So since we knew it was a right triangle, we should have been able to get that without too much work. All right, in triangle XYZ, each of the segments inside the triangle are mid-segments, which are segments that join the midpoints of the sides of the triangle. What is the probability that a point inside triangle XYZ chosen at random is from the shaded region? Okay, so remember what happens with mid-segments is when you take a mid-segment, this is congruent to both of these here. So really, the shaded region in here is 1 out of 4 equal parts. There's 1, 2, 3, and then the shaded region is 4. So it's 1/4 of the region, okay? Now remember, this region here is 1/4 of the total, but that's not what the shaded region is. It's smaller than that. So this is 1/4 of the total, okay? Now within that, we've got another mid-segment. Well, it should be 1/4 of that total. So really, we want to know what 1/4 of 1/4 is. Now within that, we've got another mid-segment. So this is the guy we're looking for. It is 1/4 of 1/4 of 1/4. Basically, if I were to draw this picture out, okay, it kind of takes a little bit of time, but it's doable. How many little triangles are there? Oh boy. Right? If I draw out these little triangles, how many triangles are there going to be? Right? It takes a little while. There's 64 little triangles in there, and only one of them is shaded. So really, it's 1 out of 64. Now that comes from 1/4 times 1/4 times 1/4. That's 1/64. Right? Remember the way we multiply fractions across the top and across the bottom? So 1/64 is going to be our answer. That's the probability that that point chosen from random inside the big triangle comes from that shaded region. All right, in triangle ABC, which of the following is true given that AD is a median? All right, if AD is a median, remember that bisects the other side. So I know that these two lengths are the same. So let's go through these. Angle BAD, right, that's this angle right here. Angle BAD is congruent to angle DAC, that's this angle here. I don't think we know that, and it doesn't look like it from the picture, not that we want to just think of it that way, but the fact that sort of imagine what would happen if this was all the way out here, right? It would start to get really, really small. So I don't think we know that that angle is the same. What about line segment AB is congruent to AD? Do we know that these are the same? I don't think that we do. So we can't really say that if we're not sure. See, the area of the triangle ABD is equal to the area of triangle ADC. That's saying the area of this triangle is equal to the area of this triangle. Well, think about the formula 1/2 base times height. This is the first base and this is the second base. Those are equal, okay? So it's almost like the area of triangle 1 versus triangle 2. It's 1/2 base times height. The question is, what's the height of this triangle? Well, it's this distance right here. What's the area? What's the height of this triangle? It's actually the same thing. So actually, C is true. The areas are going to be the same because they have the same base measurements, right? Because it's bisected. And actually, the height comes from the same thing. It's the top point all the way straight down. It's that distance. So in either one, what's crazy to think about is that if you had looked at this triangle right here, or not, sorry, not that one. It would have to be the same. Let's do this. Okay, this triangle here. See how that length, that base, let's say it's the same as this base? The area of this triangle would actually equal the area of these triangles. They have the same height because they come from the same point up here, right? So the same height. And that base is the same. So really, it's crazy to think about, but as long as the bases are the same, the heights are the same, the areas are going to be the same. So we're going to go with answer choice C. The area of triangle ABD is equal to the area of triangle ABC. All right, in the figure below, what is the value of A plus B plus C? Okay, so we need to know A plus B plus C, these three angles here. Well, first off, I've got a lot of stuff going on here. I'm gonna start writing all over this, okay? I see on the left side, I've got a triangle that has a 45-degree measured angle and 115, and then you've got this A. That's one triangle there. That should add up to be 180 degrees. So I can solve for A here. This is 159 plus A. So I know that 159 plus 21 is 180. So A is 21. All right, third of the way there. I've got this isosceles triangle here way over on the right. So that means that these base angles are the same. And since we know the top angle is 40, there's only 140 degrees left for these two. I just did 180 minus the 40 that was already there. So if I divide that by 2, I get 70 degrees. So this is 70 and this is 70. Okay, that doesn't really help me necessarily yet, but it's going to. This angle and this angle are the same because they're vertical angles. They're across the way from this intersection. So I know that this is 70. Now here I'm kind of stuck. I can't necessarily find exactly what B is because I don't know what C is. I've got this triangle. I know one side, but I don't know the other two. So I can't really find B and I can't really find C. But what I can do is I can actually find the sum of B plus C, right? B plus C have to be 110, has to be 110 because we've already got a 70-degree measure. That means the other two have to add up to be 110 because they should all three add up to be 180. We've already got 70, 70 and 110 is 180. Now, if I know B plus C is 110, all I got to do is add A to that because what I'm looking for is A plus B plus C. So if I add A, then I know A is 21. I'm going to get A plus B plus C is 110 plus 21. So it's 131 degrees. A plus B plus C. You don't have to necessarily know B and C. If you're looking for the sum, you just have to know what B plus C is. And in this case, we do. So we're going to go with C, 131 degrees. All right, which of the following could be the third side of a triangle whose side lengths are 8, 14, and X? All right, so we're looking for this third missing side here. We've got an 8 and a 14. The question is, what could the third side be? Well, let's maybe try some guess and check here, all right? What about 4? Could it be 4? Well, remember the two smaller sides have to add up to be bigger than the third side. So 8 and 4 make 12. It's not enough. You're going to have a 14 here. You're going to have an 8 here. And you're going to have a 4 here. They're not going to even be able to connect with each other, as you can see. It's just not enough. You need more distance here to connect with that, okay? So 4 is out. What about 6? 8 and 6 make 14. That's not bigger than 14. You're actually going to just have a flat line. They're going to just touch, but they're going to be flat on that 14, so it's not going to be big enough to make it actually pop out to make a triangle. So it's not actually going to be 6. What about 21? 8 and 14 and 21. Now here's the thing you have to think about. I don't add my 8 and 21 now because those are not my two small sides. Now my two small sides are 8 and 14. So 8 and 14 add to be 22. And 22 is bigger than my longest side. So this is actually going to be possible. Okay. Now, if you check the other two, they're not going to work. Because if you had a 22 here, you'd see that 22 is not bigger than 22. If you had a 25 here, you'd see 22 is not bigger than 25. So the only thing that's going to work here is that 21. So the trick to this one is noticing that when you guess and check, at some point, it'll overtake the longest side. And now all of a sudden you have to think, oh, what are my two small sides? They're not the same as they were before. Okay, so answer choice C is correct. All right, which of the following side lengths does not form a right triangle? All right, so we're looking for basically things that make Pythagorean theorem hold, which is a squared plus b squared equals c squared. Now you could plug and chug, I should say. Just plug these numbers in and try, right? 3 squared is 9, 4 squared is 16, 5 squared is 25. It's true, yes, that 25 equals 25, so it really is a right triangle. That one's a right triangle, we're good to go. Now we're looking for which ones are not, so I can actually exclude that because we're not looking for right triangles. And you could just keep plugging all these numbers in until you see it. But I think the better way to do this problem is to recognize our Pythagorean triples. 3, 4, 5, 5, 12, 13. These are our major ones. So if you see multiples of these, you know they're right triangles. So look at answer choice B. You see how it's just double what 3, 4, 5 are? So that's a right triangle. 5, 12, 13, that's a right triangle. That's our other Pythagorean triple. 10, 22, 26, I don't know about that one. Now 30, 40, 50, that's a multiple of 3, 4, 5. That's a right triangle, so it's got to be this one. Okay, so one thing you can do is narrow down a few choices that are multiples of your Pythagorean triples. Then you just have to check, right? So if I tried 10 squared plus 22 squared plus 20, or equals 26 squared, you'd see that 100 plus 22 squared, what would 22 squared be? 220 plus 220 plus 44, so 484. All right, equals 26 squared, you get 584. 26 squared, I'll go ahead and do it here. 26 squared is 676, right? And we see that on the other side, we don't get 676. We get 584, which means it's not a right triangle. All right, find the length of the missing side x. All right, so first thing, I see a right triangle here, okay? I'm looking for the missing side here. So I could use Pythagorean theorem. 3 squared plus x squared is equal to 6 squared, okay? Now, we're gonna try this, but we're gonna actually come back to this. This is a shortcut. You see how this one doubles to here? That's my short side doubling to be my hypotenuse. This is a 30, 60, 90. It's one of our special right triangles. So I know that this side is just this side 3 centimeters times the square root of 3. This is my 1, 2, square root of 3 triangle. So really, it's just 3 square roots of 3. So my answer choice is A. That's the best way to do this problem, is to recognize this is actually a special triangle. Now, if you didn't do that, that's okay. 9 plus x squared equals 36. Take away 9, you get 27 is equal to x squared. If you square root that, you get that x is equal to the square root of 27. Now, you could obviously check that on here, that the square root of 27 is this 5.19, and the only number that's going to match that is the answer choice 3, root 3, which is also 5.19, okay? That's how you'd use your calculator. But remember, it's pretty easy to break down into 9 times 3. 3 is a prime number, so we leave it as a square root. 9 breaks down into 3 times 3, which means it's basically just root 3 times root 3 times root 3. These two pair together to make a whole number, and then you've got your root 3 left over. So that's really probably the best way to do that if you don't recognize that it's a special 30, 60, 90 right triangle. All right, if segment AD is an angle bisector, find the measure of angle B. All right, so what they're doing here is they're showing that because this is an angle bisector, since AD is an angle bisector, these two angles are congruent. If they're congruent, that means they're equal to each other. So 3x minus 8 is equal to x plus 10, right? We just solve this equation, gives us 2x minus 8 equals 10. We add the 8 to both sides. We're going to get 18. So 2 times some number is 18, that number has to be 9. All right, so x equals 9. Now what are they actually asking for? They're asking for the measure of angle B. Well, we can use that x to our advantage. If I plug in x equals 9 here, I get 3 times x minus 8. That's 3 times 9 minus 8. That's 27 minus 8, so 19 degrees. So that means that this is 19 and this is 19. Also, you can verify that by plugging in 9 for x in x equals 10, or x plus 10. You get 9 plus 10, you get 19 degrees. Okay, so either way, this is 19 and 19. That makes 38 total for this whole angle. This angle here is 43. So remember, we've only got 180 to use. I've already got 43 and 38. So that's 81. So 180 minus 81. It's going to be 99 degrees. So don't forget, the picture doesn't have to look like a 99-degree angle. I mean, that doesn't look like it, but these are not drawn to scale, and you can't assume anything. You have to just kind of go by what mathematically is correct. All right, angle A and B are complementary. If angle A is 4x minus 12 and angle B is 4x plus 54, what is x? Okay, so A and B are complementary, which means A plus B must add together to equal 90 degrees. So they give us the expressions for A, it's 4x minus 12. If I add that to B, I get 4x plus 54, and that should equal 90. Now the question says, what is x? So as soon as we find the value of x, we're done. So we don't have to plug it back in or anything. We combine our like terms. We have x's both on the same side, so we combine them together to get 8x. Minus 12 plus 54, that's going to be 42. So we get 8x plus 42 equals 90. We take away 42 from both sides. That leaves us with 8 times x equals 48. Divide by 8 and we get 6. Okay, so we know the answer is E6, but I want to try this problem in a little bit of a different way. It's almost just as fast, actually. And it's using one of our testing strategies that we want to just make sure we're still good with. So these are in order from smallest to largest, right? You see how it's -2, 1, 3, 4.5, and 6. All our answer choices are in order from smallest to largest. So let's try the B strategy. We're going to guess B and see if it works. So if x was 1, then we would have 4 times 1 minus 12, that's A. And for B, we would have 4 times 1 plus 54. 4 times 1 is 4. 4 minus 8 is -4. And this would be 4 plus 54. That would be 58 degrees. You can tell those aren't complementary. They don't add to be 90. Plus also you get a negative number here. So that's weird. That wouldn't work ever. So what that tells me is it's not B, because B didn't work. And also this number is too small. I need a bigger number, right? So that means that it can't be A as well. So just by testing one number, we eliminated 2 choices. Next thing we're going to do is test D, 4.5. So we're going to plug in 4 times 4.5 minus 12, that's A. And then B is 4 times 4.5 plus 54, okay? 4 times 4.5 is 18, okay? 4 fours is 16 and a half. Times 4 is 2, put them back together, you get 18. Minus 12, that means A is 6. Over here we get 4 times 4.5, which is 18 plus 54. That's going to be 72. As you can see, when they add together, they're not quite enough. It's only 78 degrees, which tells me it's not D. Also, it tells me it's not C because this number was too small. That means it's answer choice E6. So that's pretty quick. Remember, this one works because I can tell if a number that I plug in is too big or too small. It's very clear. Sometimes it's not clear, and if it's not clear, you may not want to try that strategy of assuming that you can tell, oh, if 1 didn't work, then the number smaller than that is too small. So just something to think about. All right, the triangle ABC is equilateral and triangle ACD is isosceles. Angle BAC is 3 times as large as angle CAD. Find the measure of angle BCD. Okay, so first thing, triangle ABC is equilateral. So I'm gonna mark that all the sides are the same. And then of course that means also that all these angles are the same. And really that means they're all 60-degree angles. So I'm gonna mark that right there, okay? Then it says ACD is an isosceles triangle. So that's the little small triangle over here. It's saying that it's isosceles. That means these two sides are the same and these two base angles are also the same. Okay, angle BAC is 3 times as large as angle CAD. So what they're saying is BAC is here and CAD is here and it's 3 times as large. Well, if this one's 60 and it is 3 times as large as the other angle, if we divide by 3, we're going to get that that angle is equal to 20, which makes sense. 20, 3 times as big as 20 would be 60, so that makes sense. So this little angle here is 20. Now, in this little sideways isosceles triangle, I've got this angle is 20 and these two are equal. That means I can find each of these angles because I know they're the same. So really we have 180, we take away 20 because we already used up 20. That leaves us with 160. These two base angles have to add to be 160, so really we just divide it by 2 to get 80 degrees. So that means this angle here is 80, this angle here is 80. Now what does the question say? Find the measure of BCD. Well, BCD goes from B to C to D. That's this angle here. Well, there's a 60-degree section and an 80-degree section. When you add those two together, you get answer choice E, 140 degrees. Okay, a lot to that problem, but it's doable. All right, find the length of the hypotenuse. All right, so we're going to use Pythagorean theorem here. I guess we're assuming this is a right angle. All right, find the length of the hypotenuse. So we have a right triangle here. I know that since it's a right triangle, a squared plus b squared equals c squared. A is unknown, but we're just going to call it x. B is unknown, we're going to call it x. We don't know c, but we're looking for the length of the hypotenuse. So that's what we're going to look for. X squared plus x squared is 2x squared. If I square root both sides, I get basically square root of 2 times square root of x squared. I broke those up. You're allowed to break them up into 2 separate pieces, because if you multiply them together, they can fit under one roof. That means you can break them apart. Equals c. Remember, the square and the root cancel off here. So just to make sure you really understand this, 2x squared is breaks down into factors of 2 and x squared, which is really x and x. So really that's what I'm doing here. Break it down into the square root of 2 times the square root of x squared. That's what I've got here. All right, so square root of 2 times x, because remember the squares and the roots cancel. So square root of 2x, or x square root of 2. Okay, so that is going to be answer choice B. Now, of course, if we really were on top of our game, we would recognize that because these two sides are the same, their opposite angles are also equal. This is a 45, 45, 90 triangle. Okay, whatever the legs are, you multiply by root 2, and you get your answer much faster, right? 1, 1, root 2. So please, by all means, remember that trick. That will save you a ton of time. All right, to measure the height of a flagpole, Philip measures the horizontal distance from a point. He finds that the distance is 155 feet. He knows that the angle between the ground and the height of the flagpole measures 32.9 degrees. What formula would he use to calculate the height of the flagpole? All right, so they already give you the picture here. It's a right angle. It's kind of implied because the flagpole's perpendicular to the ground. 155 feet, we know the angle is 32.9. Basically, I'm going to label my sides as opposite, adjacent, and hypotenuse. Okay, and what am I dealing with? I want to know the height of the flagpole. So I want to know this opposite. So I'm dealing with opposite, adjacent, and an angle. Remember from our little acronym here, SOHCAHTOA, that when we're dealing with opposite and adjacent, that's always tangent. That's what the OA stands for. But right now, I can cross out A, I can cross out B, I can cross out D. It's one of these two, right? So the tangent of the angle is the opposite side divided by the adjacent side's lengths. So we know the angle, so we plug it in. So tan 32.9 equals the opposite, which we don't know, over the adjacent 155. And that's where we actually stop. If we wanted to solve this, we'd do tan inverse of both sides, but we don't really care what x is. We just want the formula. So that's why it's going to be answer choice C. Okay. The top of a 20-foot long ramp is 10 feet off the ground. What is the measure of angle A? All right, so I'm going to label my sides. This is my opposite, my adjacent, and my hypotenuse. And there, of course, is my angle A. So it looks like I want to know the angle, and I know the opposite is 10 and the hypotenuse is 20. So again, from my SOHCAHTOA, what am I dealing with right now? I'm dealing with an angle. That's all three of them. That doesn't narrow it down. But opposite and hypotenuse, that's going to be sine. So we're going to say the sine of the angle is opposite over hypotenuse. That's my formula there. Okay, so the sine of the angle, we don't know the angle, but we're going to call it A, is the opposite 10 over the hypotenuse 20. Okay, so basically when we don't know the angle, we always do the sine inverse. So we're going to take the sine inverse of the sine of A, and we're going to take the sine inverse of 10/20ths. Sine inverse cancels and leaves us with A. So really, A is the sine inverse of 10/20ths. Get out my calculator, do my second sine, that's sine inverse of 10 over 20. Now, if you reduce that to a half, let's save even more time, but we get 30 degrees. Also, don't forget, if you're not in the right mode, it's not going to say 30 degrees. It's going to give you radians. I'll just show you what that would do. If I were to do sine of 10 over 20, it's going to be this 0.52. It's a radian measure, but it doesn't really help us when we're talking about degrees. So always make sure you're in degree mode when we're doing these kind of problems. Keep you out of trouble. All right, so the answer is 30. And we can see that our answer choice C is correct. Now remember, if we were smart, we would look at this as the small side. See how it doubles to be the hypotenuse? That means this one is 10√3. We've got a 30, 60, 90 triangle. So that little observation that it's half as big should clue you into something, hopefully. That'll save you a lot of time. All this work is unnecessary if you can just recognize that as a 30, 60, 90 triangle. All right, rationalize the following fraction, 6 over square root of 3. All right, so to rationalize means to get rid of the square root in the bottom. So what we're going to do is we're going to multiply the top and the bottom by square root of 3. What we're doing is we're multiplying by 1, right? Root 3 over root 3 is just 1. So if I take any fraction, I multiply it by 1, it stays the same. So we're not going to change this. We're just going to change the way it looks. When I multiply fractions, I multiply straight across the top. So 6 times the square root of 3 is 6 root 3. Root 3 times root 3, a couple ways to think about it. It's root 9, and root 9 is just 3. Or it's easier to think about 2 matching roots, just make a whole number. Either way, you get 3. Now, I don't see this answer choice in there. A kind of looks similar, but none of these look like that. Well, it's because 6 is factored into 3 times 2. And since you have a factor of 3 on top and a factor of 3 on the bottom, they cancel. They reduce to 2 square roots of 3. Okay? Now, that means answer choice D is correct. But let's look at something real quick. I can convert square roots to decimals, right? 6 divided by square root of 3, right? That's what our problem initially said. Right? Rationalize this fraction. So it's 3.464. I don't want that to change, but I just want the way it looks to change. So 6 times root 3. Well, what is that? 6 times root 3. That's 10 something. So it's not that one, right? Is it square root of 2? No, square root of 2 is not 5.646. Square root of 3 is not 5.646. It's not 2, so it's got to be D. So using your calculator here is a pretty good trick. Just converting it into a decimal, because we always can convert things to decimals, and it's kind of like the universal language. It should all be the same. All right, ABCD is a parallelogram. If angle DAC is 4x minus 2, angle ACB is 6x minus 42, and angle D is 3x minus 10, find the measure of angle DCA. All right, so ultimately what we're doing is we're looking for the measure of DCA. Okay, that's our goal. It tells us that DAC is 4x minus 2. That's that angle right there. It says that ACB, which is ACB, that's down here, is 6x minus 42. And angle D is 3x minus 10. Okay, so first of all, this is a parallelogram. So a couple things that I know about parallelograms is that line AB is parallel to line DC. Now, if I extended this out a little bit, I'd have parallel lines, right? And then if I extended this line out, what would I have? I'd have a transversal. So basically what that tells me is that we've got some equal angles here. It kind of tells me that, actually, I'm not going to do it that way. That way doesn't actually work. What I'm going to do is this. These two lines are parallel, and here's my transversal. Okay, so basically what I'm saying is that these two angles should be equal to each other. Okay, those are alternate interior angles. So 4x minus 2 should equal 6x minus 42. Because it's a parallelogram, we know this is true, right? So if I go ahead and solve for x here, I take away 4x from both sides. I get 0, so negative 2 equals 2x minus 42. Go ahead and get rid of this 42 by adding it to both sides. We get 2x equals 40, so x is equaling 20 if I divide both sides by 2. Now, what does it ask for? It says for the measure of DCA. That's the orange angle. So that's this one here. Well, I don't know that one. I don't even know an expression that represents that, but I do know expressions that represent the other parts of the triangle. And so if I can find these two here, that means I'll be able to find the third one, because if I know two sides of, or two angles of a triangle, I can find the third. So 3x minus 10, when I plug in x equals 20, is going to be 3 times 20 minus 10. So 60 minus 10 is 50. That means this angle right there with the arrow is 50 degrees. The other one is 4x minus 2. So when x is 20, I get 4 times 20 minus 2. I get 80 minus 2 is 78 degrees. So this angle here, 78 degrees. This one is 50. So this one has to be whatever's left over. So 78 plus 50 is 128. That leaves 52 degrees left over. If I do 180 minus 128, I get 52 degrees. So I've used up 128. That leaves me with 52 degrees left. So answer choice B is correct, 52 degrees. Okay. All right, in the figure below, quadrilateral ABCD is a rectangle, and angle MNB is equal to 120 degrees. What's the measure of angle BDC? All right, so if it's a rectangle, that means that these sides are parallel to each other. Okay, and we do, it looks like, have a transversal, right? This transversal cuts through. So it tells me that these are equal. All right, MBN is 120. So MBN, that angle, I'm actually going to erase some of this stuff here. This angle right here is 120 degrees. Okay, so since this forms a straight line with this angle, I'm going to use a different color, this darker orange angle, that means it has to be 60. Okay, because it forms a straight line. That's a linear pair right there. Now the question says, what's the measure of BDC? So BDC is this angle right here. Well, if I know this angle is 60, and I know this is a right angle because it's a rectangle, 60 plus 90 is 150. That means that angle D here has to be 30 degrees. Just because of the three angles of a triangle summed to be 180. Okay, so that one's kind of a linear pair question mixed with a triangle question. All right, the following triangle is a 30, 60, 90 triangle. What is the ratio of x to y? All right, so this is a 30, 60, 90, right? This is 60 and 90. So remember 30, this is my small side. This is my one side. Remember my long side is here, the 2 side, and this is the square root of 3 side. So that's actually the ratio of things. It could be double that or triple that or 5 times that or whatever, right? It could be 10, 20, 10 square roots of 3. That's still the same ratio, okay? So basically what we're doing is we're saying x to y is going to be, well, x is some multiple of 1 and y is some multiple of 2. So it's actually just 1 to 2, right? Remember, if this was 10 to 20, 10 to 20 would reduce to 1 to 2. If this was 100 and this was 200, it would still reduce to 1 to 2. So the ratio is 1 to 2. All right, that's all I have for you today. I appreciate you guys being here, and we will see you next week.